We want to discuss the quotient rule, which is what allows you to take the derivative of two variable functions that are divided. So if you have variables on top and bottom, that is called a quotient, and we can apply the quotient rule. If we let the top function be f of x and the bottom function be g of x, then the derivative with respect to x is always equal to g of x times f prime of x minus f of x times g prime of x, all divided by g of x quantity squared, which to me is a mess. It does look like the product rule on top. The only difference is rather than adding them, we subtract them, okay? But the bottom is just the original function squared. So there is a saying for this, and I don't know if you'll like it or not, but what we do is we call this the high function and this the low function, and we say that this is low times the derivative of the high function, so we say low d high, minus, this is the high function, high d low, this is the derivative of the low function, over low, or low squared. So that's how I learned the quotient rule, so I wouldn't get it mixed up. Low d high minus high d low over low. It's up to you. You can memorize it either way. It doesn't matter.
That sounds like something.
But that's how I memorized it. Low d high minus high d low over low. Most college professors are not going to sing that to you, okay? But that is how I learned it. Low d high minus high d low over low. And my brain just kind of can sort it out from there. Low function, high function. And guys, on the product rule, it doesn't matter if you get them backwards which term comes first, but it does matter on the quotient rule because when we subtract, it matters which term comes first. So you have to do the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So however you choose to memorize that, but you do have to memorize it. For our first example, we want to find the derivative of y equals the quotient 5x minus 2 all over x squared plus 1. So basically, this is how you find derivatives of rational functions. In order to take this derivative, the first thing you have to do is identify the top function and the bottom function. So we have y prime equals the bottom function, so low. And since it's a binomial, it needs to be in parentheses until you're certain that you don't need them. So low d high, what's the derivative of the top? Minus the top, and it needs to be in parentheses because it's a binomial, times the derivative of the bottom, which is, okay, all over the bottom squared. And that needs to be in parentheses as well. So one more time. We took low d high minus high d low over low. Any questions about the calculus? And guys, that's it. The calculus is done. It's just kind of a one-shot kind of deal there. Any questions so far? Okay. You are not allowed to stop at this point because you have a subtraction sign outside of parentheses on the top. I want to caution you, however, that you cannot simplify this function with this one. That is not going to work because they don't all three have it. You have three terms here. We have 2 on top and 1 on bottom. If all three had it, you could reduce it by a factor of x squared plus 1, but they don't. So you have no choice but to distribute the top. So the top will become 5x squared plus 5 minus 10x squared minus 4x all over the bottom squared.
You don't have to square that out?
You do not. You only have to distribute if you have addition or subtraction outside of parentheses, and we don't have that on the bottom. In fact, we want to leave the bottom because we want it in factored form at the end. Any questions so far?
Is that supposed to be a minus?
Minus what?
5x minus 2. No, it's wrong.
No, it's wrong. Isn't it wrong? Yeah, I definitely messed that up. We should fix that. Thank you. So this should be a minus, which will make this a thanks. Okay, one more time. That was terrible. Low d high minus high d low over low. Thank you. Okay, so does that fix everything? And now you guys, when I distribute the minus 2x to the minus 2, it becomes positive 4x. And that was the only thing that I had messed up there. So on top, now we need to combine like terms, and we get negative 5x squared
Plus 4x.
plus 4x
Plus 5.
plus 5 all over x squared plus 1 quantity squared. And I do not believe that the top will factor because nothing will multiply to negative 25 but add to 4. Is that correct? Okay, so we are finished.